Hello and welcome back to lesson 3.4 part 3. We're going through these lists of justifications for logical statements in the flow proof. Let's see, what have we justified so far? We've justified this bit about the line of reflection, causing this to be perpendicular. How about the fact that the line of reflection, again combined with the fact that equilateral triangles fold onto themselves, makes the D the midpoint? That is also the definition of reflection. Yes. Okay, reflection doing a lot of work here. How about D is the midpoint of AB means that these two segments are congruent? Well, that's the definition of midpoint, pretty sure. Six. How about the fact that CD is equal to itself? Well, we know that's the reflexive property, so not a definition, but a property of mathematics. Boom, 17. And this has always bothered me, like this is not part of any other flow. That just pops into existence right there based on the diagram itself and the reflexive property itself. All right. What else do we need? Well, if this is a side and this is our angle, oh yeah, we can do side angle side, but not, see, I was trying to do side angle side with these two sides and this angle that's not between them, right? Oh, my triangle's not there. Here's the fact that the equilateral triangle, all the sides are equal. Here's the angle we have, and then here is the midpoint split, and that is side, side, then the angle. I was trying to do that in the last video, and it wasn't working, so we ended up using hypotenuse leg instead, which works because these are same logic, only we have to notify that it's a right triangle. But because we do have this, we could do side angle side. We could use the center shared side, the right angle, and then the midpoint split. So that is side angle side. Let's use that. That's this one, and the angle in between them, which makes side angle side pop into existence right here. Later in this video, we will actually use side, 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 the best one. That side, and the equilateral triangle side. 3 sides, so we could be using side, side, side right here, but this time we'll use side angle side, which is 14. How do I know that? Awkwardly, it's not on this page. There we go. Okay, well, this is CPCTC. We know once you prove a triangle is congruent, then you can say its parts are congruent, and that's 16. That one is on here. Corresponding parts of congruent triangles are congruent. And then once we've established that the line segment is perpendicular, and of course it touches the top of the triangle, which I believe is point C, we've then established the definition of an altitude. Definition of an altitude is 7. I bet you definition of a median is going to prove that one. How about definition of an angle bisector for this one? Sure, number 9. Are we going to have to do definition of a perpendicular bisector here? Yes, we are. That's 10. We're leaving anything out? Nope, looks pretty good. Okay, some students just came and talked to me for 5 minutes, and I can't remember what I was saying in this video. But I think I was going to say something like, we're going to use side, side, side here in a second. Oh, I think that's why this is so weird, like this pointer, like it could collect anything. This flow diagram's a little tricky. Maybe too tricky. Maybe that's why we skipped it originally, but we're coming back around. Okay. Travis and his friend. Okay, oh, I know what I was going to say. Turns out they're all right. It is an altitude. It is a median. It is an angle bisector. It is a perpendicular bisector. It's all four of those things because it's an equilateral triangle, which is perfectly balanced out. If it were not an equilateral triangle, if it was a scalene triangle, there would only be one of these things. If it was an isosceles triangle, could it be all? Could it be all of these things if it was an isosceles? It could. I think isosceles also. These can all overlap. Okay. Travis and his friends have seen their teacher write two-column proofs in which the reasons justifying a statement are written next to the statement being made. Travis decides to turn his argument into a two-column proof as follows. So instead of flowing through the diagram and putting the justifications as little numbers, he will just make the statement, ABC is equilateral. That was given. C is a line of reflection. Equilateral triangles can be folded on themselves about a line of reflection. D is the midpoint of AB. Well, that's the definition of reflection. After you've shown that AB has landed on itself, which they did in this line. Segment AD is congruent to segment DB. That's the definition of a midpoint, which we established here. So sometimes I like this. You number this, 1, 2, 3, 4, 5, and you reference back line 3. Definition of reflection, that was in line 2. Okay, that's all we need really right now. And then lastly, he gets his proof right away. He's done. Definition of a median. What's the definition of median? Well, it hits the midpoint. And also, see, I don't like this proof because they aren't referencing the fact that the median also has to touch the other vertex. I guess he... So... I'll let CD intersects opposite vertex given. This should be at the top of the diagram. Call it line 6. And then definition of median. That's line 4 and 6 combined. These two things combined make it the median. Let's do Clarita's proof. Clarita wanted to prove it's an altitude. Let's do Clarita's proof. Clarita wanted to prove it's an altitude. So what did Clarita need? Oh, she just needs this, the reflection, perpendicular, right angles. I'm gonna add CE intersects D. Given. That's the thing that they've been ignoring. Altitudes and medians have to touch the opposite vertex, the top vertex, which is, I've stated, because it's in the diagram. Given. Diagram. Check it. Maybe the line of reflection thing helps with that. No, I don't think so. I think it's a separate fact. CE is line of reflection. Equilateral triangles are folded onto themselves. About a line of reflection. This is a little confusing classically, this sort of justification wasn't really used in two-column proofs, but we're stating this is a line of reflection. How do we know it's a line of reflection? The dude folded it in half, and it folded onto itself. If that happened, we know it's a line of reflection. Okay, great. But if it is a line of reflection, and it folded onto itself, I guess, this is where it gets a little sloppy. We know that segment CD is perpendicular to segment AB. That's the definition of reflection, I believe. Yes. Because any line that folds onto itself, which AB folds onto itself, any line that folds onto itself in reflection has to be perpendicular to the line of reflection. That's part of the definition of reflection. Okay, a little uncomfortable there. But this one, at least, we can say with confidence that angle CDA and angle CDB, C, D, A, C, D, B, these ones, the right angles in there, are right angles. That's the definition of perpendicular. And lastly, then we can say CD is an altitude, because based on this and this, that's the definition of an altitude. Okay. Carlos, what you got? Oh, Carlos is the one who wants to say it's both things. Ooh, his proof's the longest. Okay, go ahead and set up a two-column proof. You got this. Statement, write small. Write really small. I don't know how small you got to write. Got to follow the purple line. And combine this with this. These are all the justifications. And you will have Carlos's proof. Oh, let's do Tahani's proof together, though. I kind of love this, though. Okay. ABC is, whoops, gotta write small, equilateral, given. Therefore, segment BC is congruent to segment AC. That's the definition of equilateral triangle. Okay, that's one side. We're going to use side, side, side. Okay, Tahani's trying to prove it's an angle bisector. We can prove it's an angle bisector if we can prove that these are the same, these two angles at the top. We can prove these two angles at the top are the same if the two side triangles are the same. We can prove the two side triangles are the same a bunch of different ways. This time we're going to use side, side, side. So far we use the outside sides are the same because it's an equilateral. We're going to use reflexive here and then midpoint logic there to get side, side, side. Okay, so let's go straight for the reflexive one. This segment in the middle is congruent to itself. That's reflexive. Property. Using the midpoint logic is a little bit more lame. Okay, here we go. CE is line LOR. Let's call it the, remember the LOR, line of reflection? That is given. And then D is the midpoint of AB. That is definition of reflection. That's not how you spell reflection. I'm going with it. No regrets. Don't look back. But then A to D has got to be congruent from D to B. If D is the midpoint, then A to D is the same as D to B. I don't know. They always like to go left to right. I like to go inward, but whatever. BD, DB, same thing. That's the definition of midpoint, which we just established in the previous line. Now we've established this, and now collecting lines. Okay, I'm just going to label them 1, 2, 3 here. 1, 2, and 3. That side is side and side. So we can now confidently say that triangle. What are the two triangles called? CDA, starting at the top, going down, is congruent to triangle CDB. Those are the left and right triangle. Side, side, side. I like to put a little note here. Lines 1, 2, 3. And if the triangle is the same, then the angle DCA and DCB, those two angles, DCA is congruent to angle DCB. CPCTC. Corresponding parts of congruent triangles are congruent. We just established the triangles are congruent. Now we can say that these corresponding parts are congruent. I wonder if we have to be really redundant and say, like, these two angles are corresponding, given, or see diagram. Nah, we're going to skip that. We're going to jump straight to CD. Segment CD is a angle bisector. Definition of angle bisector. Okay, the last thing I'm going to say is, why can't we just say definition of angle bisector? We've established the definition of an angle bisector, which is that the two side angles are congruent. Once we've established the conditions for an angle bisector, we say, well, then we have one. Why do we have one? Well, that's what the definition is. The definition of the angle bisector is the fact that those two angles are congruent. And then you can follow up the chain of reasoning. How did we get that those two angles are congruent? Well, we proved that the triangles they're part of, that their corresponding parts of, are congruent. How did we prove that? Well, we established that these three sides, these pairs of sides have to match. How did we do that? Well, read the proof. I'm not going over it again. And thus concludes 3.4, the best lesson ever. I think that's probably enough for one day. We'll do the homework tomorrow. Bye.